In section 3.6, we're going to be work with modeling direct variation. And what we're going to want to be able to do when we get done with this section is write and graph direct variation models. And our key vocabulary for this section is direct variation. And what is the constant of variation? What does that mean? So when we take a look at direct variation is a relationship between two variables x and y in this format. Y is equal to a times x. Okay, and you might see it also written as y is equal to k times x. I'm a little more familiar with it being written as y is equal to k times x, where a does not equal 0. And the non-zero number a, in this case, or the k down here, is called the constant of variation. And y is said to vary directly with x, meaning that as x changes, there will be a similar change in y. As x increases, y would increase. As x decreases, y would decrease. And that's what direct variation looks like. Okay, so also if you compare this y is equal to a times x to our slope-intercept form y is equal to mx plus b, you can see that the constant of variation is the slope. And you can also see that the y-intercept is 0 on a direct variation model. Okay, so those are just some things that you would get used to for direct variation. If I wanted to go ahead and check to see, is this direct variation? I'm going to try to put it into this form. So I'll have 2y is equal to negative 8x. And then I'm going to divide by 2, y is equal to negative 4x. So yes, this is a direct variation model. If I do this one over here, y is equal to negative 2x plus 3. Now you see, because my y-intercept isn't 0, no, this is not a direct variation model. It's a little different. Okay, so if we want to go ahead and graph direct variation equations, the first thing I'm going to do is put it into the standard form by adding 1.25x to either side. And if I want to go ahead and graph this, it's pretty straightforward. I can do it just like I do graphing in slope-intercept form. I know my y-intercept is at 0, and I know that this is my slope. So if I go 1x, that's 1 1/4 y, and then that can be my graph. Okay, and of course this would really continue in both directions. I sort of made it look like a ray, but that's really not what it is. Okay, so that's how you would graph a direct variation model, very similar to what we've already been doing. If I want to identify and write a direct variation model, then I can take a look at these two items here. I see that I've got y is equal to negative 3 when x is equal to 4. If I put those into my direct variation model, right, y is equal to a times x, if I put negative 3 in for y and I put in 4 for x, then what I can do is I can solve for a by dividing both sides by 4. So a would be equal to negative 3/4. Then the next thing I would do is I would go ahead and write out the direct variation model. Y is equal to a, which in this case is negative 3/4, times x. That's my direct variation model. Then find the value of y when x is equal to 8. So if I plug 8 in for x, the 4 will go into the 8 and leave 2. 2 times negative 3, y is equal to negative 6. That's the answer to the second part of the question. Okay, so by taking a look at this graph, I was able to create the direct variation model. and then evaluate that model for a different supplied value of x. Okay, so what our direct variation models look like, you'll see they may have a positive slope, they may have a negative slope. Right, in this case, this is a positive slope. In this case, this is a negative slope. But you'll notice that the y-intercept is always here at 0. Okay, taking a look at this in context, I have a saltwater aquarium, and the number of tablespoons of sea salt, which we're going to call S, that is needed in the saltwater fish tank varies directly with the number W of gallons of water in the tank. A pet shop owner recommends adding 100 teaspoons of sea salt for a 20-gallon tank. So write a direct variation equation that relates W and S. Okay, so when W is the number of gallons of water in the tank, we're talking about a 20-gallon tank, so that's going to be 20. And the number S of teaspoons of sea salt, they said, is 100.
It's a feat that only seems...
So if this case, you can see that, right, remember, I know that the W is going to be the X value, or the independent variable, because as I change the gallons of water, that's going to change how much salt. It isn't that we change how much salt and consequently we add more water. That's not the model they're describing. So if I go ahead and divide both sides by 20, I know that A is equal to 5. So I know that S, the number of teaspoons, is equal to 5 times the gallons of water. Okay, so how many tablespoons of salt do I need when it's a 30-gallon tank? It's going to just be 5 times 30, which is equal to 150 tablespoons of salt. Okay, so if you're confused about which variable is which, as we were going, instead of using X and Y here, we were using S and W. Remember, the way the problem is written, what is the thing you're going to change? And the thing you're going to change is going to take the place of X. In this case, we were changing the number of gallons. So the number of gallons of water went in place of X. If we take a look at using the direct variation model as a ratio, I can, by dividing this equation by X, I can get Y divided by X is equal to A. And now it's not in the direct variation model, it's in a model to solve for the constant of variation. But the ratio of Y to X will always be a constant for all non-zero data pairs. So if I wanted to start working with this, so I have the cost of downloading the number of songs. So again, my cost is going to be equal to A times the number of songs I buy, right? So again, this is going to, S is going to be X, and cost is going to be Y. So I know that 2.97 divided by 3 should also be equal to 4.95 divided by 5, which should be equal to 6.93 divided by 7. So I'm going to go ahead and use a calculator to do that. And let's just make sense. 2.97 divided by 3 is 99 cents. Okay, so in this case, A is equal to 0.99. If we take a look at the next one, 4.95 divided by 5, you see it's also 99, and 6.93 divided by 7 is also 99. So though if we wanted to write the direct variation model, Y to C vary directly with S. Well, the cost is directly related to the number of songs you purchase because the songs each cost 99 cents. If I want to write it as a direct variation model, I know that the cost is equal to $0.99, 99 cents, almost a dollar, times S being the number of songs we buy. Okay, and that's working with direct variation.